All right, so I think we're finishing up section 1.4 with this example, well, these two examples. It's a little different. Guys, we started. You guys were quiet until I started recording, then you started talking. What's going on? So here we go. We're going to, this is going to be a little different than we did before. We're not using that U substitution stuff. We are solving equations by factoring. I think we've done something like this before, but they just kind of, they ramped it up a little bit, made them a little bit tougher, okay, solving by factoring. We've done some basic ones like this before, but now making them a little bit tougher. So, oopsie daisy. So this is example 7 in the book. So if you look in the book, it's example 7. And again, you're solving for x, thank you. Here we go. X to the 4th equals 4x squared. So it looks easy enough, right? It's pretty short. It's not super long. All right, no big deal, right? Well, it's a little bit trickier. When I was looking at this problem earlier, I was thinking, maybe you're thinking of doing this. It's not right, okay? But maybe you're thinking of this. It looks like we could get rid of this x squared, right? Wouldn't it? Looks like I could divide by x squared, doesn't it? Okay. I wouldn't want to square root it because that would make it kind of ugly. I mean, you could square root this, I guess. That's a 2. But you don't want to do that. And I'll tell you why. Because if you divide by if you divide by an x squared, what you're doing is you're getting rid of potential answers to your problem, okay? You hear what I said? If I divide by an x, or an x squared in this case, I'm getting rid of possible solutions to my answer. I don't want to do that. So I'm not going to get every possible answer that I could get. You might get one of the multiple answers that you're supposed to get, or maybe even 2, but you're not going to get them all. So you do not want to divide by an x squared on both sides. Everybody hear that? Okay, so what I want to do is I want to move everything to the left, set it equal to 0. Because we're used to these quadratic things, aren't we? Where it's equal to 0. We can solve using the quadratic formula. We can solve using that substitution thing. There's a lot of things we can do when we have it as a quadratic. So let's do that. So let's move this over to the left-hand side. And that's pretty simple. We just subtract it from both sides. So I get x to the 4th minus 4x squared equals what? 0, because I subtracted 4x squared from both sides. This is the way we want to go, because I didn't get rid of any of the x's. Okay, I still have the x to the 4th. I still have the x squared. Agreed? So now, where would I go with this? You probably could substitute if you wanted to, okay? But the title of this lesson is Solve Equations by what? Factoring. So let's see if we can factor this instead of doing a substitution. I didn't do it by substitution, but my guess is you probably could, and you could probably still get it right, okay? But here's what I'm going to do. I'm going to factor out a common factor. Is there anything in common with both of those right there? An x squared. Good. So let's do that. Let's factor out an x squared. Okay? If I factor out an x squared from this, what am I left with? What's x to the 4th divided by x squared? X squared. Okay? You see why? Because if I multiply to get back to this, x squared times x squared is x to the 4th. Minus 4. Now, if I factor out an x squared from this x squared, it's just a 1, right? 4 times 1 is just a 4. Okay? Everybody with me on that one? Yeah. We've done that a bunch of times, haven't we? Factor out a greatest common factor. We've done this next part. I don't know if a bunch of times, but we've done it quite a few times. You could, if you wanted to, you got two things multiplied together. You could just set them both equal to 0. But I'm just going to do it a little different because this is the way I did it. What I would do is factor this parentheses right there. It's one of their special factorings. Do you remember the name of this special factoring right here? You got a minus. This is being squared. Something's being squared to give you this. It's called a difference of two squares. That's right. Okay, so I'm going to keep this the way it is. Can't really do much with that. So I'm going to factor this. Again, it's something that we learned earlier. And that's why we learn stuff earlier, so we can use them later. All right, that's why we learn that stuff. So let's factor. What's this going to be? Oops. It's got this little button on this pen, and my thumb accidentally hits it, and what it does, it just, wherever you write it, it just moves it all around. I don't know. So it seems like every class I do that at least one time. I wish they would put that button right where you put your fingers to. It's just ridiculous. But anyway, x and x, what's this going to be? Plus 2 minus 2. Remember how to factor greatest or difference of two squares? Well, if you don't, go back and watch. I can't teach that to you again. All right? But that's how you factor it. Now look, I got 3 things that are multiplied together and they equal 0. So guess what we're going to do with all 3 things? Somebody said it earlier. What are we going to do with them? Set them what? Equal to 0. Right. Set everything equal to 0. So set that equal to 0 because they're all being multiplied, correct? And my answer is 0. So if any of those things is 0, then it's a solution to my problem. Or 2 of them could be 0, or all 3 of them could be 0. So that's what I'm going to do. I'm going to make all 3 of them equal to 0. Because any of these could equal 0. And I'm going to set this equal to 0. Okay? What do we do here? Square root, right? To get the x by itself. Well, we did this already today, didn't we? On one of those other problems. What's the square root of 0?
0.
Just 0. Do we have to put plus or minus here?
No.
Because 0 is 0, right? There's no positive. There's no negative. All right, so there you go. Right here, what's x equal to here? Negative 2. What's x equal here? Positive 2. All right? Yep. Pretty good. All right, now, if you want to be safe, you can plug them back in, see if it works. Let's just try it. Shouldn't be that hard. Put a 0 in for these. What's 0 to the 4th? What's 0 to anything?
0.
It's 0. Okay. What's this? 4 times 0 squared. 0. Does 0 equal 0?
No. Yes. Yes.
It does. All right. So we can circle it. Let's do the easier one first. Let's put the positive 2 in for this. So 2 to the 4th. What's 2 to the 4th? 2 times 2 times 2 times 2. That would be 16. Correct. Equals 4 times x squared. So 2 squared is 4. Does the left side equal the right side? Does 16 equal 16? Yes, it does. So can I circle that? I can. Let's try negative 2. Put it in for this. What's negative 2 to the 4th? That's also positive 16. Let's put a negative 2 in for this. What's 4 times negative 2 squared? This is 16 as well, because negative 2 squared is positive 4, right? It's not negative 4, it's positive 4 times 4 is 16. So all 3 of them work. It seems like, remember we said before, whatever your highest exponent is, that's how many answers we're going to get most of the time. Why do we only get 3 answers when it's x to the 4th? Well, it's because of this. The x squared equals 0. It's kind of like positive 0, negative 0. So that's where that other answer would have been. Okay, if this would have been like a regular number, you would have gotten 2 answers for it. Does that make sense?
Yeah.
That's why you only get 3 here. Okay? Everybody good?
Yes.
All right.
Look, I have a question.
Good.
On a quiz, if I just put x is equal to 0 and then plus or minus 2.
It's fine. Yeah, you could have written x equals plus or minus 2. That would have been perfectly fine instead of writing them separately. Yep. Now in the book, they write it like this, but they put it in the braces thing and they put negative 2 first, then 0, then 2. Right? I've said that enough where you should get the idea, right? When you look at the answers in the book. Okay. We got one more example to do. How about that? Yeah. We are moving. All right. Example 8. Example 8. And it says to solve. All these say to solve for x. All right. Check this one out. This one's a little bit trickier. But once we get by the first step, the rest are not so bad. Okay? How many answers do you think we'll get on this one?
Oh, great.
Most likely 3, because this is an x cubed right here.
I'm
It's not always going to be that, but it's going to do it this time. All right, now here's the tricky part. If I just gave this to you and let you sit there and think about it, most of you probably wouldn't come up with what we're going to do right now, okay? So let me show you, all right? So I'm not going to make you sit there and think of what to do. What I'm going to do is this. If you look at these two right here, do you have a common factor? More than that. X squared, right. If I took these two, do you have a common factor with both of those? You got a 4, don't you? So what I'm going to do is I'm going to do some factoring, but I'm not going to factor something because there's nothing in common with all 4 of these, is there? No. I can't say X because that doesn't have an X. I can't say 4 because these two don't have a 4. So there's nothing in common with all 4 of them. But if I split them up, there is something in common with this, and there is something in common with this. You with me? Now, you got to be very, very careful here. Now, here's the part where you got to be real careful about, okay? I'll tell you what, I'll just write it down. I was going to do it in that little part. Anyway, it doesn't matter. Just watch. So, oh, there it goes again. Don't know, I keep touching that thing. So, watch. I've got x cubed, minus x squared. What I'm going to do is I'm going to put it in a parentheses so it separates it. Instead of that little bracket thing that I wrote in yellow right there, I'm going to put it in parentheses. Now, here's what you got to be super careful about. I hope you're watching. If I put a minus here and I put a parentheses here, can I put a 4x? Is that minus 4x right here? Yeah, this is minus 4x, isn't it? Yeah. What? What do you mean no? There's a minus and a 4x. That's a minus 4x. This is not a trick question. Okay? Is this a minus 4x? What? What's to think about? Is that a minus 4x? No. Well, what is it then if it's not? What? This right there, it's not a trick question. Listen, I promise you, I'm not trying to trick you up. Is this a minus 4x? Yes, it is. Absolutely. This is a minus 4x. I told you, it's not a trick question. Okay? But watch very carefully. Don't write this next thing down I'm going to write. I'll tell you when to write. Don't write this. Okay? A lot of people would do this. Now watch very carefully. A lot of people, don't write this. A lot of people would write this. But can you do that? Because is this the same as this thing right here? It's not, because I would have to distribute a negative. The first part's okay. If I distribute this negative through this, that would be minus 4x, correct? But if I distribute this through this, that would be a negative 4, but that's not a negative 4. How would I make this a positive 4? I would make it what, Riley? I would make it a minus 4. See what I just did? That's the hardest part of this whole problem. Right, what I just did right there. It doesn't look like it's difficult. It wasn't real long or anything. It wasn't a lot of math involved. But you have to understand, if I put this in parentheses, and I put a minus right here, if I distribute it, it should equal what I have up top. Does this, if I distribute it, equal this on top? It does, because it's minus 4x and it's minus a negative 4, which is a positive 4. Make a mental note. Make a note in your notes that you're writing right now. Put something in there that says, make sure you change this. If this is a negative. Now, if this was a positive, I could have just put parentheses around it and not worried about it. But it is a negative. It's a minus. Okay, if I put parentheses around this, I'm going to have to change this sign in the middle. Because if I didn't, then if I distribute it through, this should have been a negative, and it's not a negative. Okay. That's the hardest part of that whole problem. So now what I'm going to do, remember what I said earlier when I put those yellow lines right there? What am I going to do to this parentheses right here? I do have something in common. So I'm going to factor out a what? Greatest common factor. Greatest common factor. All right. So what's in common with both of these things in this first parentheses? An x squared. Let's factor it out. If I factor out an x squared from this, what am I left with then? X minus 1. Correct. Put the minus here. Now, what's in common in this parentheses right here? A 4. So I put a 4. It's not an x. I don't have an x in common with both of them. I only have a 4 in common with both of them. So I put a parentheses. What's left over if I factor out a 4? X minus 1. Well, it's not really a substitution. It kind of looks like you could do that substitution, but you could go easier than that, okay? Now look what you have. let's go back to the yellow since stay color coordinated. Now, look at this and look at this. All right? Anybody still with me? Okay. Is there anything in common with both of these? X minus 1. Exactly right. So what I'm going to do is I'm going to factor out, and we did this earlier in the year. I remember doing this stuff earlier in the year. Okay? So this is not new. It's been a while, but it's not new. So I factor out an x minus 1. I'm going to keep it in parentheses. Then I can put another parentheses. If I factor out an x minus 1 from this, what am I left with? What? This one right here, an x squared. Hope you guys are watching. You guys are tuned out. I can tell.
Yeah, I'm distracted right now. Coach Ken's only have 10 minutes of real paying attention.
What's Coach Ken got to do with that?
That's a cool
I'm just saying,
That's what he said.
he has
Yeah.
a preacher.
Well, you got to get over it.
He's got a nurse on
You got to shake it off. All right? I agree. I agree with you completely. Okay? But that's not reality. Reality is there's going to be times in your life you're going to have to sit down for an hour and listen to somebody talk. Okay? I promise you. Again, I say this all the time. And you're probably sick of hearing it, especially now that you're in 12th grade. But when you get in college, you're going to have people that are going to lecture. All right, forget it. I'm trying to help you, but you guys blow me off, and I get tired of it. So let's just keep going. So I don't care how long I take. I still expect it. It doesn't give you. See, you guys act. I will say it. I guess I can't stop. Okay, I gotta say it. It gets in my head, and I just can't let it go. You guys are using that as an excuse. You're absolutely. Now, do I agree with what Coach Ken said about 20 minutes? Yeah, absolutely. But you're using it as an excuse. You're like, oh, 20 minutes is over. Now I can just do whatever I want. No, you got to suck it up. You got to be mentally strong. You got to be mentally tough. Okay? Look, you go lift weights and somebody's always screaming and yelling at you. Come on, you can do it, right? That's physical. But somebody's got to tell you mentally that you can do it. All right? And you can overcome that 20-minute barrier. All you got to do is just write the stuff down that I'm writing down. That's all you got to do. Just because 20 minutes is over doesn't mean you can start talking to somebody else. My goodness, the 20-minute thing, I don't know. I got my doubts because you could sit there on video games for hours and hours on end without even moving except your thumbs. So don't tell me 20 minutes is your limit. Don't tell me, okay? Because you can overcome it. You can. So let's overcome it. All right, enough of that. I got it off my chest. I feel better. Okay, so here we go. We factor out the x minus 1. We factor out the common x minus 1. And what's left over? If I take an x minus 1 out of this thing right there, I'm just left with that minus 4. That equals 0. And now, what we can do is what we've been doing all along. You got two things set equal to 0, so let's set them both equal to 0. So let's set that equal to 0. We could factor that. We did that on the last one, or you could just go ahead and set it equal to 0 right now. It really doesn't matter. We could have factored it right here before we set it equal to 0, but let's just do this, okay? So what's x right here? X is 1. Can you do this in your head? You can do it a couple ways. We could do the factoring, the difference of two squares factoring like we did earlier, okay? Or you could just add a 4 and take the square root, and you're going to get plus or minus 2. So you're going to get plus or minus 2. So you get positive 2 and you get negative 2. You can put it together if you wanted, put the plus or minus there. Again, in the book, like on the last problem, what are my answers? Negative 2, it's 1, and it's 2. So this is the way you're going to see it in the book, right there. If you write it like this, that's fine. If you write x equals plus or minus 2 and x equals 1 like that, that's fine. I'm fine with either way of these that you write it, okay? So there you go. All right. One more homework. And it's part C, right? So here's your homework. I know I gave you lesson plans, but just in case you don't have it, it's 1-4C, and it's page 123, and we're doing 73 to 87. Did I give you all or just odds on this one? Just odds? Okay. Last year I gave all. I have that in my notes, but I was pretty sure I changed it to odds. You may. So that right there is your homework. Get that done. We're going to go over it tomorrow, and then I'm not going to give you homework tomorrow because we got a long weekend. I don't want to give you homework.
Nice.